Oh, very quickly, guys, welcome back to class. Welcome back to this continuation lesson. Welcome to Master Builders Online Academy. Guys, please get set for this new session of our mind-blowing encounter. Yes, it's an encounter because you can't watch this video and remain who you used to be. No, you must upgrade your mental capacity after watching this video. So stay tuned and ensure that you do not skip any part of this video. Why? Because every bit of this video is embedded with principles that works. I know that when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundaries. So guys, I'm super excited because we're about to gain another massive value from this video. And ensure that now that you are set to watch this video, avoid every unnecessary distractions. And also, if after watching this video once, you have questions to ask, or you are not clear with some certain steps, please guys, you have the opportunity to replay the video over and over and over again. And that's one of the reasons why these lessons are coming in video format. But if at the end of watching the video over and over and over again you have questions to ask, guys, do not hesitate. Slide down to the comment section and make your questions known to us. We will answer your questions to your own satisfaction. If this is taken and you are set to learn from this particular lesson, why not we slide down to my board as we begin to demystify the problems that we have before us in this session. In the previous video, if you are not watching that video, please go to our playlist, check under long reading so that you know the principles and the laws of long reading. Okay, so on the board, we still have the laws of long reading here on this first part of the board. While at the middle, we have problems and solutions. You find out that these problems that are here now will require us making use one or more of these principles that we have. Okay, so these laws of long reading that we have, we make use of those laws in solving these problems that we have on the board. Now, we are asked to find the value of the following. As usual, if this is log 16 to base 10, you can just punch your calculator and get your answer. Just press your calculator, go to log 16 in your calculator, and you will get your answer. But anytime the base of a log is not to base 10, you are always required to use some certain principles or laws that will help you gain an answer to such problems. But for those of us that are using very smart calculator, of course there are calculators where you can actually customize the base of the number. So you can impute the base here and impute the number, you are good to go. But what happens if you don't have calculator? How do we solve these problems? This comes with an application of laws. And that's the reason why I will please do not skip any part of this video. Now, we have the very first question on the board, which is question number 1. 16 log 16 base 2. Okay, now we find out that this log that we have here is just only one log. It's not a combination of multiple log or two or more logs. It's only one. And now we are asked to what? Find the value. That is to say that this guy has a value in terms of numbers or integer without what? Being followed by this log. So how do we solve these problems that we have on the board, knowing fully well that there is no addition, there is no subtraction, there is no power anywhere? How do we solve this? Now, should I go ahead and make use of law 6, law 7, change the base? No. Now, listen carefully. Anytime you are given problems of this category, knowing fully well that you have only one number and only one base, no relation with any other, all you need to do is to put these two methods in your mind. Because there are actually two principles or two ways this problem can be solved. Number one is either to reduce the biggest number to the size of the other number, or make use of what equation method. So we are quickly going to be using the two methods to solve these problems right away. So the first method is find a way to reduce 16 to 2. Having known that 2 is the least value between 2 and 16. So we find way to reduce 16 to 2. How do we do this? All you just need to do is to come to this side, create a table. This is 16. Now that I have it in mind that I want to reduce this 16 to 2, I will now start dividing this number by 2 using LCM table. I hope you are following me. Please avoid distraction because you are about to gain something massive. Now, look at it. So I will put down 2 here. 2 into 16, or 16 divided by 2, we have 8. 2 into this guy, we have 4. 2 into 4, we have 2. And 2 into 2, we have 1. When you get to 1, you stop. How many 2 do you have here? We have 2, 2, 2, 2, which is 4. That is to say, this is 2 multiplied by 2, multiplied by 2, multiplied by 2, which will be equivalent to 16. But we find out that in indices, if there is a best way to represent this guy here, which we know as index notation. So all I need you now is to pick one of the base, or you can equally use the laws of indices. Knowing fully well that a number without a power has a power of 1, correct? This guy has a power of 1, has a power of 1, has a power of 1. So when you have this, as this is a problem under indices, the bases are equal. Pick one of the base, add up the power. So if I pick one of the base now, I have 4 power. 1 plus 1 plus 1 plus 1 would have given us 4. That is to say, 2 raised to the power of 4 is 16. Then, in place of 16, I will put 2 raised to the power of 4. Then we have this guy as log 2 raised to the power of 4 base 2. Now we find out that at this point now, the number now has a power. So we will come back to our law table and look out for the law that aligns with this particular step we are in. So we'll come back to this session and find out when the number has a power, which law do we use? We make use of law number 3, that anytime the number has a power, you bring down the power to become the coefficient of the law. Are you with me? Are you here? Please pay attention. So it therefore shows that we can extend this guy to the word for log to base 2 using the third law of Logarithms as stated here. Now that we have gotten this, we find out that this guy here is log 2 base 2. And we equally have a law that states that the log of a number to its own base is 1. So when we come to this point, in law number 6, we have log x base x is equal to 1, which shows that the log of the same base, that means log 2 base 2 is 1. Automatically, this guy would have what? 4 multiplied by 1. And anything multiplied by 1 is that same thing, right? So automatically this guy is 4. It's as simple as this. Now for you out there who is writing objective, okay, all you need to do once you are able to get the power of 2 here, your answer becomes what you have. So now when I divided 16 by 2, I have 2 multiplied by 2 multiplied by 2, and I have 2 raised to the power 4. Once you get this, your answer is the power of 2. So the power of 2 here is 4. So you don't need to go through this Israelite process to get your option correct. No. Because in objective, the interest is to have one of the options correctly without manipulating your way out. Is that correct? You must ensure you follow the principles. So once you have one of the options accurately, following the principles that are applicable, then you are good to go. So if I were you, all you need to do anytime you are writing exams and you have problems like this, once you are able to get 2 raised to the power of anything, that becomes your answer. So when we saw going through the Israelite journey, at the end we still have this 4. So if this is not clear enough, we have other problems to solve. Now if we progress further, we have question number 2. We are still using law 1. Log of 625 to the base of 5. So when I check 625 and check 5, which one is bigger? 625 is bigger than 5. So all I need to do now is to start dividing this 625 by 5 and see if it is possible. So now we come to this section again. You have 625. 5 into 625 would have given us 125. 5 into 125 would have given us 25. And 5 into 25 is 5. Then 5 into itself is 1. That means this is 5 multiplied by 5 multiplied by 5 multiplied by 5 in 4 places. Automatically, 625 is equal to 5 raised to the power of 4. Are we on the same page? Are you here? Please let your mind be here. So therefore, we have this guy as log of 5 raised to the power of 4 to the base of 5. Now we can apply the third law of indices. The third law of what? Logarithm. Anytime the log has a power, bring that the power to become the coefficient. Then we have this as 4 log 5 base 5. We said that the log of the same base is 1. So log 5 base 5 is 1. And 4 multiplied by 1 is 4. Therefore, the answer to this question is 4. As simple as this. Now guys, let's look at question number 3. I hope you are gaining values from this class. Hope you are excited how I am holding you by the hand and walking you through the processes involved in solving problems on logarithms without depending on any other. It is very, very simple. All you need is principles. Like I said, anytime you know principles, you become a principal. And when you know boundary conditions, you will not overstep your boundaries. Now, looking at question number 3, we have log 32 base 4. So when we look at these two values, we find out that one is 32, the other is 4. The least here is 4. So we will try and divide 32 by 4. So 4 into 32, this would have given us 8. 4 into 8 would have given us 2. And 4 cannot divide 2. That means we cannot divide 32 by 4. So all I need to do now, at this point I have validated that there is no way I can divide 32 by 4 without remainder. Then all I need to do is to see how I can reduce both 32 and reduce 4 to have common number, which is very, very possible. Right? Now, for instance, I want to now work on 4. Can I reduce 4 further? Now that 4 cannot go into 32 completely without giving me a fraction or a remainder. The next thing is, can I reduce 4 to a least number and equally reduce this guy to that same least number? Yes. Go down for here. What number can divide 4 and equally divide 32? 2. So 2 into 4 will give us 2. 2 into this will give us. That's to say 4 is equal to 2 raised to the power of 2. That's for that guy. Then when we come to 32, we now have that 32 divided by 2, 16, divided by 2, 8, divided by 2, 4, divided by 2, 2, divided by 2, 1. That means 32 is equal to 2 raised to the power of 5. So at this point now, we find that we already have common base. Why are we doing this? One of the reasons why we are doing this is to ensure that we are able to apply any of the laws of logarithms that are given to us. Because without application of these principles or laws, we will not be able to solve this problem. That's one of the reasons. So we are trying to find our way to ensure that one of the laws is actually deduced from any given question. Because naturally, the question you are given may not look exactly as one of the laws, but there are steps you can take to make you arrive in one of the laws, and that's exactly what we are doing. So at this point now, it shows that I'm going to replace 32 by 2 raised to the power of 5 and 4 by 2 raised to the power of 2. That's how it is. It's as simple as this. As simple as this. Now that this has happened this way, all we need to do is, we know that at this point now, both law 3 and law 5 is applicable. Just look at it. Here, In log 3, it is the number that has a power. Now the number has a power of 5. Now in log 5, it is the base that has a power, which is this. So anytime both the power and the base have powers, all you just need to do, put down the power of the number, which is 5, all over the power of the base, which is 2. The power of the number divided by the power of the base, then all log 2 base 2. This 2 is this guy, this 2 is this guy, this 5 is this guy, and this power is this. So all you need to do, anytime both the number and the base have power, pick the number of the number divided by the power of the base. Everything will now become the coefficient of the log. That's exactly what we have done now. So at this point, this guy will cancel out because the log of 2 to base 2 is 1. Using this law, number 6, law of the same base. Therefore, our answer becomes 5 over 2, which is something as 2 whole number 1 over 2 in its fraction form. How many times will 2 enter into 5? 2 times. Remainder 1. That's the one you have as your numerator. It's as simple as this. Now, what happened to question number 4? We have the log of 3 to 81. This guy is very simple. You see, it is the same. I am not here to solve thousands of problems. No, not at all. I'm just here to guide you, give you the principles that work. While I solve few problems, I empower you to solve thousands of problems. And that's my mission. To empower you to solve more problems that I have ever solved. So when you know principles, even though I solve one, you can solve infinity problems, millions problems. Now let's look at that. So at this point, still using the same theorem, we find out that here now, none of these guys agrees to any of the laws. What must we do to deduce any of the laws of long gradients from here? All I need to do is to check the two numbers that I have. This is the number which is 3. This is the base which is 81. So now what will I do? I will find a way to reduce 81 to 3. Because I cannot reduce 3 further. Are you there? So all I need to do is to come to this table again and put 81 here. Now 3 into 81 would have given us 27. 3 into 27 would have given us 9. And 3 into 9 would have given us 3. And 3 into itself is 1. That means this is 3 times 3 times 3 times 3. Hence, 81 is equal to 3 raised to the power of 4. I can replace 81 by 3 raised to the power of 4. What I am looking for, I have seen. Then, I have log 3. 3 raised to the power of 4. So, in this case now, we find out that it is only the base that have a power. Major power. Of course, the number has a power because any number without a power has a power of 1. You remember? So if I have x, it's the same thing as x raised to the power of 1. In fact, it's the same thing as 1 x raised to the power of 1. Because the coefficient is 1, the power is equally 1. This is what we just have now. So x is the same thing as 1 x raised to the power of 1. That is to say that this guy is the same thing as what? 1 as its power. So this is 3 raised to the power of 1. And the other guy is 3 raised to the power of 4. So to simplify this guy further, all we simply need to do is pick the what? The power of the number all over the power of the base. Then log of 3 base 3. It's as simple as this. So log 3 base 3 has agreed to law number 6. Which says the log of the same base or the log of a number to its own base is 1. Are you happy that you are gaining these values for free? Guys, don't forget to let your friends know about this platform that is giving you massive value. Tell your friends about it. Share this video. Circulate it in your department, your faculty, and even in your school and time. It will help you. Yes. Now, if this is taken, therefore, it shows that the answer to this guy is 1 over 4. Knowing fully well that the log of the same base is 1, and 1 multiplied by anything remains the same. Now, finally, we have question number 5 on the board. And we have the log of 1 over 8 base 2. Guys, is this not amazing? Is this not amazing? This is what we have. Log of 1 over 8 base 2. Don't forget, you can always make use of the laws of indices anytime. Here, you can make use of the fourth law of indices. Now, the fourth law of indices states that x raised to the power of a minus a is same thing as what? 1 over s raised to the power of a. So it therefore shows that if I have 1 over x, it can be expressed as s raised to the power of minus 1. So that is what we are going to apply here. Now, if this is taken, we can equally have this guy as this to 8 raised to the power of minus 1. As long as the numerator is 1, this theorem is valid. Yes. As long as the numerator is 1, the theorem of fourth law of indices is valid here. Now that I have gotten a power here, I now have the number as 8, the base as to what else should I do? I will now find a way to make this number and this number have a common factor. And how do we do that? We simply divide 8 by 2 in number of times. And at the end, you find out that 8 is equal to 2 raised to the power of 3. Then we have this guy as log 2 raised to the power of 3 all multiplied by minus 1. And at the end, this is equals to 2. I want to equally remember that in the fifth law of indices, power can multiply power. So 3 multiplied by minus 1 would have given us minus 3. Hence, we have this guy as log 2 raised to the power of minus 3 base 2. At this point, we can make use of the third law of logarithm by removing this negative power and making it the coefficient of the number. Is this wonderful, guys? Are you mind blown already? Okay, now this will give us minus 3 log 2 base 2. Now that we have been able to have log 2 base 2, log of the same number, what do we have? This is 1. Therefore, our final answer becomes minus 3. I hope you have gained values from this class. Very, very simple. Now, quickly, I want to show you the other way to solving this problem. But I'm only going to use it to solve 1 or 2 problems. Then you can use it for others. Now, the second method is using the equation method like I explained earlier. Okay? Now, in using this method, all you need to do is to always assume the value of the log you are given in terms of alphabet. For instance, we want to solve this using method 2, which is equation method. All I need to do is to equate everything here to a letter. Let the value of this guy be x. So whatever I have as x would have become the answer to this question. I don't know the value. Just the same way when we're dealing with linear equation, what problems leading to linear equation? You remember that? John thinks of a number, then subtract 3 from the number, and then multiply the result by 5. If the outcome is 16, what number did John think of? You remember? That's it. So now we don't know what this guy will turn out to, but let's assume the answer or the end product of this guy is x. And we remember that this law is one of the laws I stated earlier under the other laws. And that's one of the laws that we just have here. Log a base s equal to n. We said that in this law, this is how the outcome becomes. And using this here, all we need to do is to what? Take the base, equate it to the number. Base equal to the number. Then what you just introduced, allow it to become the power of the base. Then just bring this x here and make it the power of the base. At this point, we are now solving indicial equation. And in solving indicial equation, all you just need to do here is to take this as 2 raised to the power of this guy. Now, when you are solving indicial equation where the unknown is taking the position of the power, all you need to do is to find a way to have equal base. Are you there? Yes, all you just need to do now is to find a way to have equal base. So I will now divide 16 by 2 to know what will be the power of 2 that will give us 16. And what will be the power of 2 to give us 16 is 4. 2 raised to the power of 4 is 16. And at this point, base, cancel this, you equate the power. Is this not wonderful? You can solve it this way. Okay, let's assume we want to do this guy, work on this guy. We will equally say, okay, let this guy be equal to y. Let it be any of the alphabetical letters. J is think of a number. I thinks of a number. I thinks of a number. It's a matter of choice. R is a matter of choice. Now, so if we have this, all I need to do is to take the base equal to the number. Then what I introduced will now serve as the power of the base. Now that I have done this, all I need to do now is check whether the unknown is occupying the position of the power. If the unknown is occupying the position of the power, all I just need to do is to find a way to make the base equal, being that they are separated with equal to. So all I just simply do here is to reduce this guy to its least base. And we know that 4 is 2 raised to the power of 2 or raised to the power of y. Then y32 is what? 2 raised to the power of 5. That's what will give us 32. Now, using the fifth law of indices, which is the product law, we said that power can multiply power. Is that correct? That means 2 multiplied by y would have given us 2y. We have 2 raised to the power of y is equal to 2 raised to the power of 5. At this point, we have equal base. And anytime we have equal base in between equal to, you cancel out the base and equate the power. Then this becomes 2y is equal to 5. Now we cannot leave our answer here, because anytime you are looking for an unknown, you must ensure that the coefficient of that unknown is 1. And if power is equally 1. Now the power is already 1, but the coefficient is not 1. What must we do to make the coefficient of this guy 1? We simply divide both sides by 2. We have 2y over 2 is equal to 5 over 2. 2 divided by 2 is 1. We have y is equal to 2 whole number 1 over 2. I hope this aspect of this teaching is helpful. Guys, don't forget to share this video. Don't forget to tell your friends about this platform. And don't forget to replay this video over and over and over again until it sinks into your mental capacity. And finally, don't forget to ask your questions at the comment section if you have any. Then I stand to remind you, if you are yet to subscribe to this YouTube channel, please subscribe to our channel. Just click on that red button, let it turn blue. Then if you need all our notifications, just turn on the post notification bell so that anytime we upload mind-blowing content, you will be notified. Even while you are in your bedroom, you are at your reading table, in the market, in classroom, anywhere you are, you will be notified. Then you can watch it at your convenient time, so you can get new values as an academician. Now guys, let's look at question number 2 very, very quickly. Now we have question number 2 on the board, and we are asked to find the value of x in the following equations. And now we have 3 equations on the board. This is not different from the last aspect of question number 1 we just looked at, as the second method of obtaining the value of a simple log. Now guys, without wasting much of our time, let's quickly look at the solution. Question number 1, we have log x base 3 is equal to 4. Yes. What do? It's very, very simple. All you simply need to do here is to equate the base to the power. Is to equate the base to the number. So this is the number, x is equal to the base. Just the same way, if you have a is equal to b or b is equal to a, they are the same. So whether I pick the number first, then pick the base later, or I pick the base first and pick the number later, is the same way. So I can choose to pick the base or the power, the number first. But here, I just decided to pick the number first, then equate it to the base. The next thing you do is that this number you have here at the right hand side of the equation must be the power of the base. So take it as the power of the base and just locate the base here. Which one is the base? 3. So put 4 here as the power of the base. And when we simplify this further, 3 raised to the power of 4 is the same thing as 3 times 3 times 3 times 3. So 3 multiplies itself 4 consecutive times, but I'm giving us 81. This is the answer to this question. It's as simple as this. Now let's look at question number 2. Roman figure 2, we have log 16x is equal to 2. So looking at this question, or judging from what we have here, is still the same thing. We already have equal to here. So all you need to do is to equate the base to the number or the number to the base. But here now I want to pick the base because the base is the unknown. Okay, let me pick the base first. So I have this is equal to the number. Here I pick the number first because the number was the unknown. So anytime you are solving this aspect, always make sure you pick the unknown first. It will make it easier for you. Okay. Here the number was the unknown. I pick x first. Here now the base is the unknown. Now I pick the base first. They are all the same. If you agree with this condition, are you there? Now the next thing I will need to do is knowing that this is my base and this is my power. Whatever that is coming at the right hand side must be a power to the base. So these two now would have been what? The power of x. That's all. How do we solve these guys? This is taken as x is equal to plus or minus the square root of 16. Now the square root of 16 is 4 because 16 is a perfect square. Therefore, our answer becomes plus or minus 4. This is the answer to this very question. Now guys, what happened to question number 3? For question number 3, we have log x base 2 is equal to minus 7. It's the same thing. I have a log equal to a number, a constant. All I need to equate the number to the base. So in this case now, the number is the unknown. So I'll pick the unknown first, then equate it to the base. Now whatever I have at the right hand side as the constant would have come and then become the power of the base. Here the base is 2. That means I will have 2 raised to the power of minus 7. Now using the fourth law of indices, x is equal to x raised to the power of minus a is equal to 1 over x raised to the power of a. If I use this step here, then I'm going to have 1 over 2 raised to the power of 7. That's the reciprocal. Okay, now that I've gotten the reciprocal of this, what is 2 raised to the power of 7? 2 raised to the power of 7 is actually to multiply itself 7 consecutive times. So 2 multiplied by 2 is 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16, 16 multiplied by 2, 32, 32 multiplied by 2 is 64, which is then multiplied by 2 is 128. Then we have this as 1 over 128. This is the value of x. So very shortly we have question number 3 on the board. Now we are asked to find the value of the following. Now the first question we have, if this is our solution, we have number 1 log 16 base 3 over log 32 base 3. So you find out that in this question, we have log 16 base 3 divided by this. Now, from the laws that we have here, we never had division law except that we converted from this guy to this. But in this case now, this is a division law. We have a division here. The numerator divided by the denominator. And each of these guys have different log. So all I need to do is to find a way to simplify the numerator independently, and same happens to the denominator. So while I'm dealing with the numerator, I'm equally dealing with the denominator. There is no certain law that is applicable to combine these two in one. Are you there? No law that combines these two guys in one. Then, if this is taken, all I need to do at this point is find a way to reduce 16 to its least space. And of course, you find out that there is no way 3 can divide this guy. It is impossible for 3 to divide 16, and it is equally impossible for 3 to divide 32 without remainder. And here we are not dealing with decimals, as you all know. All I need to do now is to just work on this reduce 16 to its least value. Then we know that 16 is 2 raised to the power of 4 base 3 all over this guy is 32 is 2 raised to the power of 5 to base 3. Now for the numerator, working on the numerator, we find out that the number has a power. Quickly we are going to make use of law number 3. So we can remove the power. Same thing we are going to do at the denominator. Hence, we have this as 4 log 2 base 3 all over 5 log 2 base 3. So you find out now, if I have 2x over 5x, remember that x will cancel x, and at the end, your final answer will be 2 over 3. Now look at this. Log 2 base 3 divided by log 2 base 3 will give us 1. That means this guy can cancel this guy. Automatically, this will give us 4 over 5. This is the answer to this question. Solve the numerator differently, solve the denominator differently, then use any of the laws that you are able to deduce from the question. And at the end, you can cancel out. As long as this is log 2 base 3 divided by another log 2 base 3, they will cancel out. Hope this is taken. Now, if this is not fully taken, now let's look at question number 2. Now, for question number 2, we have 3 log root 5 over log 5. Of course, we know that this particular question, we do not have a log to it. And you understand that anytime you have log without a base, indirectly, you have it to base 10. But we are not going to introduce the base. As long as this is not carrying a base, this guy is not equally carrying a base, that means both of them are to equal base. Fine. Now, what do? We find out that here, this is 5. This is root 5. The first thing I will do is to remove the square root. So now, look at it. The square root of x is the same thing as x raised to the power of 1 over 2. In other words, the square root of 5 is the same as 5 raised to the power of 1 over 2. So we quickly remove this square root. Then this will have given us 3 log 5 raised to the power of 1 over 2 all over log 5. As simple as this. Now, remember that at the numerator, the log 5 has a power. And we know that we can quickly make use of law number 3 to remove the power. And if we remove this power, automatically this guy would have given us, actually give us what? 1 over 2 multiplied by 3 log 5 over log 5. At this point, log 5, cancel log 5. And then we have 1 over 2 multiplied by 3. 1 over 2 multiplied by 3 is same thing as 3 over 2, or 1 whole number, 1 over 2. This is it. So, when you have division between two logs, this is how you solve it. You work it out. Just be dealing with the numerator, dealing with the denominator, and ensure that at the end, something is common between the numerator and the denominator. Hope you are gaining massive value from this wonderful session. Okay. Now we have Roman figure 3. And in this question, we have log of 125 to base 2 all over log of 5 to base 2. Now the numerator is to base 2, the denominator is equally to base 2. And the numerator, the number is 125, the denominator is 5. So what must I do to this guy to deduce the same thing that I have at the numerator at the denominator? Or the one I have at the denominator at the numerator? All I will do is to reduce 125. Of course, we know that there is no way we can divide 125 by 2 to have a value without decimals. So all I need to do now is to just reduce 25 to a base of 5. And 125 is the same thing as 5 raised to the power of 3. 5 raised to the power of 3. So, automatically, this will have given us log 2, 5 raised to the power of 3, all over log 2, log 5 base 2. Now, log 5 base 2. Now, at this point, when we check the numerator, we find out that the numerator has fallen out to be one of these logs, which happens to be log 3. And anytime the number has a power, we pick the number to become the coefficient of the log. Now we have this as 3 log 5 base 2 all over log 5 base 2. So log 5 base 2 cancel log 5 base 2, we are just left with 3. This is the answer to this very question. Then finally, the last but not the least is this guy, number 4. And for question number 4, we have log, Roman figure 4, we have log 243 to log 27. This is what we have. Now, at this point, guys, this is a log without a base. This is a log without a base. That means it is to base 10. Number 1. The number 2 is, how can I reduce this guy and equally reduce this guy to have a common log? To have this done, I will just find a way to reduce 243. And we know that 243 is not divisible by 2 if, for instance, we want to use the LCM table. Similarly, 27 is not divided by 2 if we want to use the LCM table. But 243 and 27 are divisible by 3. So in a nutshell, 243 is the same thing as 3 raised to the power of 5. And 27 is the same thing as 3 raised to the power of 3. So by extension, we will replace this guy by this and replace 27 by this. Then we have this as log of 3 raised to the power of 5 all over log of 3 raised to the power of 3. So now, dealing with the numerator and the denominator independently, we will check what law does the numerator agrees to and what law does the denominator equally agrees to. Both agrees to law number 4, law number 3. Both agrees to law number 3. So we are quickly going to make use of law number 3 by removing the power and making the power the coefficient of the log. Then we will have this as 5 log 3 over 3 log 3. Now that we are able to deduce log 3 base 10 at the numerator and log 3 base 10 at the denominator, log 3 cancel log 3. So the coefficients becomes our answer. Finally, the answer to this is 5 over 3 or 1 whole number 2 over 3. This is the answer to this very session. Guys, we find out that question number 1, all the problems we solved under it were principle based. Question number 2, all the problems we solved under it were equally principle based. Question number 3, all the problems we solved under question number 3 were all principle based. Do you now see that you cannot gain mastery of this topic at all if you don't know principles? And now, have I actually added values to your life by helping you understand the principles that work? Now, I told you earlier, if you know principles, you become a principal. When you know boundary conditions, you will not overstep your boundaries. If at this point you are yet to subscribe to this channel, do consider subscribing to this channel and ensure you turn on the post notification bell for more exciting videos. Guys, have you shared it to your friends? If you have not, please kindly share this link to your friends so that they can equally watch this video and gain values to themselves. Please don't be selfish with it. Let your friends get to know about this platform. God will bless you. So don't forget to check the description below where you will find the link to the next video. See you guys in the next class. Thank you for watching. God bless.